Okay students, here I'm going to solve this question for you. So in this question you can see a sample of hydrated double salt. Double salt mean a salt that may contains two cations or two anions, and in this specific salt you can see there are two anions. One is cation, one this the ammonium ion and the copper ion. So two cations are there, that is why we can say this is a double salt, and only one anion is there, so that is why it is a double salt. So then we are going to proceed. Was boiled in an excess of sodium hydroxide. As a result, ammonia gas was given off. Then ammonia produced was absorbed in 40 centimeter cube of 0.400 mole per dm cube hydrochloric acid. The resulting solution required 25 centimeter cube of 0.12 mole per dm cube sodium hydroxide to neutralize. Then the first question says that write the ionic equation for the reaction between ammonium ions and hydroxide ions. So here is the ionic equation. Remember, the ammonium ion has the formula NH4 1 plus, whereas the hydroxide ion has the formula OH negative ions. When these two react together, it will release ammonia, which is NH3 plus water. So this should be the ionic equation. Then in next part, B1, he says calculate the amount in moles of hydrochloric acid. So all the quantities are given. Whenever we are provided with the volume and concentration, we are going to apply the formula N equals to CV, C times V, where C is concentration. So I'm going to put the value of concentration, which is 0.400, and we have to multiply it with the volume, which is 40.0 divided by 1000, so that the volume in cm cube must be converted into dm cube. Okay, to convert the dm cube volume of cm cube into dm cube, we divided it by 1000. So the final answer we will get is, I'm going to calculate this one. So 0.400 multiplied by 40 divided by 1000. So the answer we got is 0.016, as we calculated the moles, so unit is mol. In next part he says, and remember one more thing, this was the excess amount. Okay, this was the excess amount. Got it? So few of the acid will react and some of the acid will not. So resulting, he says that the resulting solution required. So whatever the amount of acid left, it requires this amount of the sodium hydroxide to neutralize that acid. So first of all he says calculate the amount in moles of sodium hydroxide. So I'm going to find the moles of sodium hydroxide, NaOH. How? By using again the same formula, as volume and concentrations are provided. So the concentration is 0.12, multiplying it with the volume, which is 25, but again it is in centimeter cube. To convert this into decimeter cube, we are going to divide it by 1000, and overall the answer we got is, dividing 25 divided by 1000 and then multiplying the answer with 0.12, which is concentration. So the final answer we got 3 times 10 raised to the power minus 3, which is also, we can write it in decimal form, which is 0.003, and the unit is mol. Then next he said calculate, this will be equal to the amount of hydrochloric acid left. Why? Because when we react NaOH and HCl together, what we got? We got Cl plus H2O, as the molar ratios are same. So what amount of the sodium hydroxide we have, that much hydrochloric acid will react. So as he said that This amount is exactly required to neutralize the remaining amount of the acid, and the amount mole of the sodium hydroxide are 0.003, mean the hydrochloric acid which was left over after the reaction is 0.003. Got it? So next part, calculate the amount in moles of hydrochloric acid that reacted with ammonium. For this we have to say what was the total amount of the acid. The total amount of the acid was 0.016 in the first part, whereas the leftover amount was 0.003. Now what amount we reacted with the initially ammonia was, subtracting this value, this is 0.016 minus 0.003, giving us 0.013 mole. So this is the amount of the acid that is reacted initially with the with the ammonia. So again, the ratio for the ammonia and NH3 plus HCl, this will produce what, NH4Cl, and you can say the ratio are the same. So the amount ratio is 1:1. If the amount of the acid we got left over that is initially reacted with the ammonia was 0.013, so the ratios are same. That is why the amount of the ammonia will remains the same, yani 0.013. Got it? Next, he says that the sample contains 0.413 copper. So now the question is turning towards the copper, and it says that use the information and your answer to calculate the value of the x, this x. So first of all, I'm going to convert the mass of the copper into the moles of the copper. Okay, so how we know that mole of copper is equal to mass of copper, which is 0.413, divided by AR of the copper, which is 63.5. You can use this value from the periodic table. Okay, so when we go to divide this value, 0.413 divided by 63.5, as a result we get 6.5 times 10 raised to the power minus 3, and to convert into decimal it will be 0.0065 mole. Now we have the moles of the copper, we have the moles of ammonium ion or ammonia. We can say like this, the ammonium ion is there, so even we can say this amount is NH4 ions, ammonium ions, okay, that are producing. Again, it has the same ratio. So what we are going to say, we are making the ratio with ammonium ion NH4 positive. So the moles we got for the copper is 0.0065, whereas the mole for the ammonium we got 0.013. To convert into the simplified whole number ratio, we are going to divide it with the smallest number, okay, and the smallest number is 0.0065, and in this case 0.0065. When 0065, it will be perfectly cancelled out, giving us value 1, whereas when we divide this, which is 0.013 divided by 0.0065, the answer we got is perfectly 2, giving us that in this formula, when we have one copper, the ammonium ions will be 2. When we have one copper, and you can clearly see we have only one copper, so ammonium ion will be 2, mean the value of x is 2. The value of x is 2. So we can say, so x is equal to 2. Finally, now we put the value of x over here. As a result, the formula we got will be CuNH4 whole twice dot SO4 whole twice. Okay, now what we have to say, question, calculate the MR. So we are going to find the MR of this compound. For the MR, we know that one copper atom into its atomic mass, which is 63.5, plus we have two nitrogen atoms into the AR of nitrogen 14, plus 8 hydrogen atoms into the AR of hydrogen 1, okay, plus 2 sulfur atoms into the AR of sulfur is 32, plus 4 times 2 8 oxygen atoms into the AR of oxygen is 16. So when we solve all this, what we got is 63.5 plus 28 plus 8 plus 64 plus 8 times 16. So the answer is what we have to say, 1 minute, 63.5 plus 28 plus 8 plus 64 plus 8 times 16. The answer is 291.5. 291 point, or you have to calculate it, okay, properly. Ammonium. Understood? So in this way you can calculate.